Hello everyone, welcome to my video. Today I'm going to show you the current progress of the etracer vacuum tube curve tracer, and I'll show you the demo on the current board with everything on the board, including the high voltage power supply, the negative grid supply, and the filament supply. So here I'm going to show you the target spec of etracer. So this is based on my current evaluation board. This is a minimum spec, like I'm comfortable with. The plate voltage from 0 to 750 volt, and it's adjustable in a 1 volt step. The current is 240 milliamp maximum, and the current measurement accuracy is 0.1 milliamp. The grid negative supply goes from minus 0.1 volt all the way to minus 160 volt. And adjustable in minus 0.1 volt step. And I don't provide any current reading on the negative supply because its accuracy is a problem, because we're talking about the microamps. Okay, for the filament supply, currently I'm using a buck converter. It's switching power technology, and it's adjustable from 1.25 volt to 20 volt in 0.1 volt step, and the maximum allowed current is 2 amp. Okay, this is the minimum target for the for etracer. So I'm still thinking improving the filament supply, so hopefully I can get the current to 3 amp. I'm also thinking increasing the supply voltage to 26.5 volt. So this way we can measure some tubes, like late tubes that designed for series connection of filaments, like the filament voltage is 26.5 volt. For example, so it's not trivial. So maybe I'll stop at the 20 volts. So, but in any case, the worst case is 2 amp. So the target of 3 amp is actually for the transmit tubes. I really hope a single machine that can test all the supply all the voltage for and current for transmit tubes like GN70. And currently it's very difficult to give a very accurate current measurement, because with the switching power supply, the voltage noise on the supply is very, very high, so I cannot get a reliable current reading. So I'm investigating throwing another linear voltage regulator. So hopefully after that I can get a more stable reading, then I can provide meaningful current measurement. So this is the best case. This is the what I want to achieve. But even even we don't have that, we still have the minimum spec, and I think it's pretty good enough. If you look in the market, this is I think this is best in class for all indexes. Okay, so and let me show you the current software, and I'll show you the a measurement against the 12AX7. It's a very high mu triad, so accuracy is a challenge. Okay, so this is setup data for 12AX7. So after we downloading the setup data, the scale will scale properly, and the volt heater volt will be loaded in this field. So we can now, sorry, it's not connected. So we can now, okay, the machine is not turned on. Okay, so let's do it again. Connect. The software is still buggy, by the way. I think it's normal at this stage of the development. So let's switch on the heater supply. So here you can see the voltage reading. So you can see the reading is quite noisy. It's a gift from switching power supply. So maybe I'll throw in a couple passive filters like inductor and capacitor to, hopefully I can get the more stable reading here. But I did check the voltage on the oscilloscope. It's quite stable, so don't worry about the number here. Okay, so the filament heat up. So now we can scan around the curve scan. Okay, so I had a problem with the grid voltage, because what I found is once the filament heat up, even I don't supply any plate voltage, I measure a negative voltage on the grid. So and it has to do my hardware architecture. So my hardware architecture, I cannot pull the grid lower than what's currently at the grid. So for example, if the grid is currently at it's minus 0.2 volt, and if my setup is 0 volt, I cannot pull the grid to 0 volt, because the grid is already more negative than my setup. So to solve that problem, I had a special circuit that if the target grid volt is 0, I'll force the grid to ground. So and that's why I mark this line blue. Okay, so the curve tracing is done, and you can see even I'm using a switching power supply as my filament supply, I can still get a very nice smooth curve here, because I use a lot of DSP technologies. So I believe after I move to the PCB printed circuit board, and the performance will be much better. But even now, I think this result is very acceptable. Okay, so I'm going to work on the print circuit board. So hopefully I'll give you an update like in 1 month or 2, and showing you the real PCB and the test result with the PCB. Thanks for watching my video. Hope you guys have a nice day. Bye bye.